Let's look at OpenStax College Physics, Chapter 3, Problem 65. An athlete crosses a 25-meter wide river by swimming perpendicular to the water current at a speed of 0.5 meters per second relative to the water. He reaches the opposite side at a distance 40 meters downstream from his starting point. How fast is the water in the river flowing with respect to the ground, and what is the speed of the swimmer with respect to a friend at rest on the ground? All right, let's start looking at our knowns and unknowns and drawing the diagram. So we're told that the river is 25 meters wide, so the width of the river is 25 meters. And we know that the swimmer, the person, is swimming at 0.5 meters per second relative to the water. So I have velocity of the person relative to the water is 0.5 meters per second. And I know that the river is going to take him 40 meters downstream, so I'll call that, I don't know, X, I guess. And that is 40 meters. And my unknowns are how fast the river is flowing with respect to the ground. So I want the velocity of the water relative to the ground. And I also want the speed of the swimmer with respect to a friend on the ground. So I want velocity of the person relative to the ground. That's what I called my subscripts. So let's look at the diagram. Here we have the river, and it has a width W of 25 meters. And we know that the swimmer starts somewhere here, swims across the river with a velocity of person relative to the water. We also know that the water stream is going downstream, obviously. So that is the velocity of the water relative to the ground, and that means that the swimmer will go in this direction. So this is velocity of the person relative to the ground, and will end up a distance of 40 meters downstream. So that is my 40 meters there. So the only vector that we know here is the velocity of the person relative to the ground, just this one. But if we look at the triangles here, the triangle between the velocities and the triangle between the distances, we notice that they're similar triangles. So from knowing that this is 25 meters and that is 40 meters, I can figure out this angle right here. And that's going to be useful for my vectors here. Now, I also have a cheat sheet. I have my equation here for relative velocities, for addition of relative velocities. I start with subscript A here and also in the sum. I end with subscript B in the sum, and then this C will drop out. So let's see if we can write the sum of the vectors that we have here, the velocities, in the same way. So I'm looking for velocity of the person relative to the ground, and that would have to be velocity of the person relative to the water plus velocity of the water relative to the ground. And if I look at my vectors here, I notice that the velocity of the person relative to the ground is indeed the sum of the velocity of the person relative to the water plus velocity of the water relative to the ground. I have a tip-to-tail addition. I'm adding this to that, and then this is my resultant vector. So let's start out by solving for this angle. I'm going to call it theta. So I know that theta is inverse tangent of what I labeled x divided by what I labeled w. So that's inverse tangent of 40 meters divided by 25 meters. And that turns out to be 58 degrees. So now in the velocities triangle here, I know that vector and I know that angle. Using trig, I can solve for both the velocity of the water relative to the ground and the velocity of the person relative to the ground. So I'll do just that. I will say that cosine theta is velocity of the person relative to the water divided by velocity of the person relative to the ground. So it's adjacent divided by hypotenuse. So velocity of the person relative to the ground then will be velocity of the person relative to the water divided by cosine theta. So that is 0.5 meters per second divided by cosine 58. And when I plug in the numbers, I get 0.94 meters per second. So the swimmer is swimming at a speed of 0.94 meters per second relative to the ground, relative to his friend on the ground. Now, if I use tangent theta is velocity of the water relative to the ground divided by velocity of the person relative to the water. So velocity of the water relative to the ground will be velocity of the person relative to the water times tangent theta, and that is 0.5 meters per second times tangent 58. So velocity of the water relative to the ground will be 0.8 meters per second.